So look at the syllabus. This is the week of the 12th. So we're still kind of ahead, which is good. So I think what I'm going to do is we'll do just 3.8. And I'll send you a video of the review later and the notes. The next week, we'll talk about a test exam date, probably the end of the month, and do 4.1. So next week will be, I guess, chill on lecture, but you have to start preparing for test 2. But we'll talk about that next week. For now, let's get to 3.8. Let me see here. Write this down. Newton's method. So basically what we're doing is we're applying this formula right here. And it's an iterative method. So Newton's method will find a zero or approximate the zero of a function, assuming that the derivative is not zero because you got to divide by it. And you're given an initial guess. Okay, now the guess, I mean, you can, if you're programming this yourself, you kind of choose your own initial start. You kind of want to try near a zero if you can kind of guess, and if not, it doesn't matter. Giving enough iterations, eventually it'll approach the actual x value that gives you an output of 0. So all you want us to do is do this iteration twice. Okay, so this homework is just gonna have you do each little step one at a time. And then the final box is the actual output, which will then go into here, which will then do the same thing. Okay. Let's get out Desmos real quick. So essentially, we're going to be estimating one of these zeros. So as we do the iteration method, it'll get closer and closer to this. Since we're choosing 2 to start with, we will approach this one because it's closer. So let me write this question down. So number 1, I'm not going to fill in all the boxes. Well, I'm going to do it all at once so you can see, but I'll break it down. Calculate 2 iterations of Newton's method f is equal to x squared minus 7. Starting point is x1 equal to 2. And the actual xn is equal to, yeah, this is how I'll write it. Give me a sec. And I'll switch over. All right, can you guys see this? So this guy is the next point, and it uses the current point to calculate your iterative method. So if I'm plugging in x1, right, I'm going to find x2 using that. Or if you're plugging in x0, whatever. But notice we need the derivative. So f prime will be 2x. We also need the function at x naught, or xn. So I'm going to start here. So look at our little boxes, right? This guy, this starting point for n equal to 1 is here. Here, plug in the number, right? So we need, let's see, how do I keep this neat? F of x1, which is equal to f of 2, is equal to 2 squared minus 7, which is 4 minus 7, negative 3. Now we also need the derivative at that same number. Right? So these are all the pieces we need. So that means that, so at this point, use the formula and plug in this info. So now x2 would equal x1 minus the function at x1 divided by the derivative at x1. Does that make sense? So just plug it in, that's it. x1 is 2 minus, this guy would be negative 3. This will be 4. So 2 minus 3/4, that'll be a 2 plus 3/4. What is 2 plus 3/4?
It's 11/4.
11/4, thanks. Okay. So now we found x2. So f of xn, that the first thing that we did right here was plug it in. Got negative 3. The derivative at that number, we got 4. Dividing them would be negative 3 divided by 4. The entire thing, we got 11/4, right? That's what they're asking. Just plug in the pieces. So now x2 is what we found, is right here. Now plug that into the function and plug it into the derivative and do the same thing. So you just do that forever, and eventually you approach the 0. But of course, we're humans, not robots, so we're only going to do it twice, just for fun. Any questions on the first iteration? Okay, so far, not bad, right? So now, repeat this. To repeat this, to find x3, basically, which is equal to, right, x2 minus the function at x2 divided by the derivative at x2. So this will be what x3 is. So see how the results keeps going back in the formula over and over again? That's why it's an iterative method. And that's why we use coding, because this is ridiculous by hand. First iteration. Second. So here we go. x3 is equal to, I'll just go ahead and write again for consistency. That will be 11/4 minus. So I need to find this guy. So over here, we'll do some side work because I'm out of space. F of x2, that's going to be what? F of 11/4 u. That'll be 11/4 squared minus 7. These numbers, as you can see, and the second iteration usually it gets pretty messy. It's not hard, it's just, again, more for programming than anything else. Okay. So this becomes 9/16 over. Now the derivative at x2, which is equal to the derivative at 11/4, that will be 2 times that, so 22/4. They're 11 halves. Okay, so what is this gonna be? So on here, right? F, that would be the 9/16. This will be the 11 halves. Divide them both, and that's the next part. I think I need a better calculator, so I need 9/16 divided by 11 halves. Okay, so about 10.7. As a fraction, that would be 9/88, right? So this division is 9/88. Double check. Yeah, there it is. Okay. So this piece is 9/88. This one would be the subtraction. 11/4 minus that, so 4 times that'll be what? 22. 4 times 22 is 88, so we need to do 22 on top and bottom. This would be 242 over 88 minus 9/88. 233 over 88. That would be x3. So that would be approaching closer and closer to 2.46, right? Let's see how close it is. Yeah, check it out. It's super close, 2.64. So each iteration we do gets us closer and closer, but we're pretty much there, almost there. Anyway, do you see what they're asking on number 1? You're just following this formula. Okay, so you guys are cool? Because the whole homework is the same. I'll pick something that's a little different. Let's do 5, because 1 through 4 is just repeating the same thing. It's just follow the formula. So you guys cool on the formula before I move on to something harder, right? Nothing on the first iteration or what these pieces mean. You guys, okay. All right, cool. Number 5, basically you're gonna do the same thing. The only difference is you kind of have to set it up. So they're saying that, or something you should know, if you set 2 functions equal to each other, then when you solve for x, that'll be where they intersect, okay? So they say, well, if you subtract it over, set it equal to 0, then that we can call that h. So basically you're doing you want to know when this thing is 0? Because that's the same thing as saying when these are equal. Does that make sense? Here. This is number 5. Find points of intersections. Set f of x, let me phrase that better.
Hey, do any erasers work on those friction pins, or does it have to be those erasers on the pins?
It's friction pins are based on heat, literally the friction. So any kind of heat or you can also wipe it away with water. The only caution, I just caution you to, if you use these, make sure you scan them right away, because in Texas, if you leave them in the heat, you risk losing notes. But yeah, just anything that makes it heat up when you erase it. Just don't pick a material that'll stain this, because then you can't write on it. 2 find points intersection of 2 functions. F of x and g of x. Simply set them to equal to each other. So that's how you find intersection points. I'm assuming you've done that before. If you forgot, well, there it is. Oh, there's highlighters too. That's pretty cool, anyways. I had no idea. So if you set these equal to each other, right, and then you subtract them, then you get it set to 0, right? So if you find out when this is equal to 0, that's the same question as to when are they equal. You see what I'm saying?
Say that. Can you repeat that, sir?
Yeah, so if they're equal, that means when you subtract them, you would get a 0, correct?
Oh, okay.
So if you find out what x value does that, then that's the same question from a different perspective, right? So what they're doing right here is they're saying, well, if I want to find an intersection point, that happens when they're equal. So create a new function, which is the difference of these two, and find out when that's 0, which means you can apply Newton's method. So Newton's method can be used indirectly to find an intersection point. because you can solve for this, because Newton's method finds zeros. But this zero implies an intersection. Does that logic make sense?
Yes, it does.
Okay, then let's just use this. So f of x, let me write it down, is equal to 2x plus 2, and g of x is equal to the square root of x plus 8. Kinda, at least. That's basically what you do. But what we want, right? What we want is to use this function instead. H of x. So the difference. So we're going to apply the formula, right? Xn plus 1, the next one, is equal to the previous one minus the function at that previous point over the derivative at that same point. So they told us to use what? Points. Oh, they didn't tell us. Okay, well, let's try number continue the iterations until two successive approximations are less than 0.001. So you may have to do it a couple of times. Hopefully not more than 2. We can see the intersection, right? It's right there. So I'm going to pick the number 1 just because it's easier. I don't know. It might be a mistake. Maybe 0 is better. So x 2, which is what I'm looking for, is going to be 0 minus the function at 0 divided by the derivative at 0. I'm going to need the function. I should use, in this case, I'm using h, right? Oops, 0. Derivative of h. That's going to be 2 minus 1 over 2 the square root of x plus 8. I skipped the derivative step and just did it in my head there because we're focused on the formula. Is that cool, or get rid of this, that guy? All right, I'm going to move on. So plug in 0, but plug in 0 here, right? H of 0 will equal 2 minus square root of 8, whatever the heck that is. I need to pull out a calculator. Two minus square root of 8. God damn it. I think I have this calculator here as a button. Do not want exact, yeah. I forget how to turn that off. 1 sec. There it is. So that'll be negative 3.66. The derivative at 0 will be 2 minus 1 over 2 square root of 10. So this is 1.84. Okay. Alrighty. So then we get 0 minus negative 3.66 over 1.84. I'm gonna go ahead and use all the decimals just because I can. Okay, so that'll be negative negative, so that'll be 0 plus 1.99. All right. Hopefully I am, well, actually I don't have the function set up. Let's go see what it is, just so we can tell if we're getting close or not. Because this is kind of tedious. So the answer is 0.454. So we gotta do another one. We're not even that, we're not very close. For the original, oh, I'm sorry, hold on. Is that the function? Yes. Okay. So this will be x2. So use it again. So now x3, so this first iteration, second, x3 will equal x2 minus the function h at x2 over the derivative at x2. So as you can see, you can get pretty tedious. What I recommend is just kind of use this to help you out. I'm gonna call it, I don't know, W for no reason. Okay, so the original is right there. The derivative was 2 minus 1 divided by 2 square root of x plus 8. All right. So h of 1.99 is this. So that can save me some time. H of 1.99 will equal 2.82. Okay, cool. W of 1.99, this is the derivative. H prime at 1.99 will be approximately 1.84. Okay, cool. So now I can just go straight up, plug it into the formula, right? Make it easier. So x3 is equal to 1.99 minus 2.82 over 1.84. So what is that approximately? No idea. $0.57. Which is we're getting closer, right? What did we say it was? 0.54. So you do it one more time, and then you'll get within that tolerance they're requesting. There won't be much of a change. So once the change is less than this, you plug in your X value that you found. That makes sense? This
What
is
did what did you change on the calculator to get your answer?
what do you mean? Like what I plugged in or
No, did you switch it from uh, a certain?
oh
I
to
don't.
get like to get rid of the
Yeah.
exact stuff? Just press this button right above the enter. That should do it for you. If you have this one. Like if you had square root 2, right? I want the decimal. Just press that button.
So like that 2 minus square root of 8. Um, let me see.
Yeah.
So I got -2 square root of 2 plus 2, but you got oh, I think you got -4 or 4, and mine's set to degrees. So yeah, you got -4 square root of 2 plus 2. But I got -2.
Hmm.
So do I have to change the settings on my calculator to scientific or something, or?
You had four root 2 minus 2. Is that what you're saying?
Oh wait, was hold on. Okay, hold on. 2 minus 2 square root of 8. Oh no, never mind.
Oh, you see it? Okay.
Yeah, I saw it. Okay, thanks.
All right, cool. Just making sure that there's nothing
Okay.
wrong on either end.
Just it's just me burnt out.
I hear you, man. I hear you. All right. So that'll be the second ratio. You would do it one more time. I'm gonna try to shorten it up because this is very tedious. X4. So what you'll have to do is plug in the one you found earlier, do the same deal. So over here, I'm going to do H of 0.457 and just use the calculator, graphing calculator on the machine, on the website. Do the derivative. And then we'll just plug it in and make it easier. And after that, we'll have the exact one we want. So this guy is 0.457. So the derivative at that location is 1.828. H is 0.006, I guess. So then And then we have 0.457 minus 0.006 over 1.828. So now it's pretty close, right? It's not changing much. Anyway, does anyone have any questions on this method? That's all you're gonna do in the whole homework. Just apply the formula a couple of times and move on.
Could we look at number 6 as well, please?
Number 6. So this will be the same. I'll set you up because I do want you to try it out. So basically, here, let me see. I'll start out for you. So we have h of x equal to f minus g, where f is 9 minus x squared, g is e to the x over 2. So basically, you're going to have to do iteration a couple of times, but notice that there's 2 zeros. So if you choose a number to start on that's closer to the right-hand side, let's say you start at 1, right here, then your iteration should take you closer and closer to this one. If you choose like -1 or -2, then it should start taking you closer and closer to -3 as you do your iterations. Okay. So
Okay. Yeah.
this, oops, what's that? So h of x is equal to 9 minus x squared minus e to the x over 2. The derivative is equal to -2x minus 1/2 e to the x over 2 once you do all your derivatives. That looks ugly right there. Okay. So remember, formula we're using, the next point closer to the 0 is equal to the one you first chose minus the function at that value over the derivative of that value. So if you choose right, you want to keep doing them until the answer no longer changes, Isabella. So if you keep doing it over and over again and you notice no change, that's what they mean right here by the iterations differ by less than 0.001. So if I were to do it again, nothing would change except like maybe 6 or 7 decimal places down the line, you'll see a small difference. So if the third decimal place is no longer changing, then that's good enough. Move on. Okay. That's what they mean. Usually that'll happen in like 2 or 3 attempts. Okay, so make a note here and let you work on it. To find the 0 on the left, choose something close. So choose x1 equal to, I don't know, look, they gave us a graph, so 2, I guess. To find the 0, I'm sorry, that should be right. The hell? For the left one, choose x1 equal to -2, I guess. You can choose whatever you want. But usually this method will approach the closest one from your starting point. Okay. So don't choose another one that's really close to the 0 you already found, because you'll probably end up in the same spot. So try to pick something further away. That's why I chose these two. Does that logic make sense?
Yes, it does. Thanks.
Okay. All right, guys. Let me take roll and we'll call it a night here. And we'll talk about the exam 2 review, and I'll send you notes next time.